Alrighty. Hello, everyone. So I was asked if I could put out a quick video explaining the order of those items in Lab 4, the Planet Formation Lab. And I was like, sure, that's a good idea, actually. So let's do that. All right. What I will do is I will explain the general process, and then I will at the end swipe to reveal the items in the order. Okay, I won't do that yet. Okay, so if you haven't or don't have the lab pulled up already, if you want to go ahead and do that, right, to follow along. So feel free to pause and then come back to it. Okay, so to start, out in interstellar space, you have gas and dust, right? A collection of which is called a nebula, right? So that's the first one, a cloud of interstellar gas and dust. It begins to collapse under its own self gravity, right? Enough of the gas and dust are close enough together to gravitationally pull on other pieces of gas and dust, right? And over time, a long time, more and more of these pieces collect and they form a denser and denser clump, okay, or a denser and denser nebula. So let's see. First, I'll just write all out in interstellar space. We have this giant, amorphous, very low density gas cloud, right? A nebula. Secondly, that nebula begins to, right, contract. Okay, contracting under gravity to some central point. Okay, and that contraction, right, the process of the particles along the outside moving inwards, the particles out here have more potential energy than the particles towards the inside. And so that means that under the force of gravity, these particles have further to fall, right? They move further than particles closer inside. They just go that far, okay? So that means that the particles that started out way out along the outer edge, they're moving faster by the time they get to the center than the particles that started closer in. Okay, and so there you have a difference in motion of the particles. Okay, so number two, gravitational potential energy from the collapse is converted into heat, right? The difference of those particle speeds, right? These ones fall in faster than these. They come in and collide into the particles in the middle already. And that collision, that friction, creates heat. All right, so number three, let me try and fit it in here. Number three is as that nebula or gas cloud collapses, right, it begins to slowly rotate. So I'm going to try and draw this something like this, right? It begins to turn. How do I do this? Like that. Okay? It rotates about that axis. And in so doing, the top and the bottom, if you will, kind of move inwards, right? They fall inwards, they squish. And so it goes from initially being pretty spherical, right, to a disk, to more of a disk that's turning, not unlike our galaxy. Okay? So that's number three. The cloud of gas rotates faster and faster due to conservation of angular momentum. Right. Number four, right? As that gas cloud is rotating faster and faster and becoming more and more into a disk, let me kind of do a top-down view now. Right. So I'll draw the axis again. And if I were to draw the disk, actually, sorry, let's do it this way. Let's do this. Let's keep direction consistent. Let's do this. There's the center. Something like that, right? It's not a galaxy, it's just a nebula, right? The particles that are out here are moving slower So I'll draw it like this, a small arrow. It's moving slower than the particles slightly further in. They're moving a little bit faster. Okay? And the particles even further in, say the ones in here, are moving really fast. Okay? And it's this difference in speed that again is causing another source of friction. Okay? The particles inside are moving faster than the ones outside, and so that means that these inside collide with those outside, and they clump together, right? Kind of like a shearing force, or if you think of, say, two race cars driving around a turn on a racetrack, the car on the inside will pass by the car on the outside. Okay? But in this case, those two grains actually collide. And because of that, they stick together. And this is happening all across this disk, or all across the nebula. These collisions are happening. And so these planetesimals are getting bigger and bigger in size. So this is number 4. Motions push grains back and forth past other grains, and smaller grains stick to larger grains. Okay, that's number 4. Number 5, do it this way. Excuse me. Number 5, as these planetesimals are forming, right, they're going to look something like this. Again, a top-down view. We have the center here. We have all of these planetesimals around here, right? All of these small clumps of solid rock and whatever, okay? The bigger ones will start to attract the smaller particles. Okay, so a couple of these may be really big. So these larger planetesimals will start to attract the smaller planetesimals. Right? And then over time, those planetesimals will continue to grow in size. Right? This is how planets are formed. So number 5, planetesimals form that have enough gravity to attract other planetesimals. So really, at number 5, there's no longer that much gas in the space, right? Here and here was a lot of gas, right? It was a giant gas cloud. But starting in number 4, we're starting to see individual planetesimals form, right? With less gas in between. Where does that gas go? Well, it's sucked up by the planetesimals, or you'll see it's blown outwards to the outer part over here. Okay, so number 6, what happens if these larger planetesimals continue to attract and swallow up, I guess, the smaller planetesimals? Well, this continues. Planetesimals continue to grow, and continue to grow until, well, they're full-blown planets. And so here's the center again. And now we might have an actual planet there, an actual planet there, maybe an actual planet there. We have individual planets in this solar system all moving around. Okay? In their orbits, and I'll continue to draw this with dotted lines. Very crudely. All of these planets, whoops, hopefully you get the, in fact, that was a terrible solar system. Let's start over. There's the sun. Let me draw the orbits first. That might be a good idea. Okay, now just be aware that those dotted lines here are not planetesimals. They're the actual shape of the orbits, right? And I only did that to show you the paths that these actual planets now will take. Okay, again, not planetesimals anymore. We have actual planets. Okay, so that's what's happened. That's the culmination, if you will, from step 4 to step 5 to step 6. Right? These tiny planetesimals here became medium-sized planetesimals over here, which became large planetesimals or just planets in number 6. Okay? So that's number 6. Accretion continues with planetesimals growing in mass and becoming planets. And then lastly, number 7, you may have guessed already, inner planets become small and rocky while outer planets become gaseous. So we have now our center or the sun now, and the inner planets, let me just draw solid rings, I guess. Inner planets are solid and rocky. Right? We have 4, Mercury, Venus, Earth, and Mars. And then the outer planets, I won't have room to draw all of them, but these are the big ones, and these are gas giants. Why are they gas giants and not rock giants? Well, the inner sun, right, the central protostar, its solar wind has pushed back and blown away all of the very light gas particles. It's pushed it out to the outer part of the solar system. And all that gas that was pushed away has collected in these giant planets out here. All of the heavier rock has fallen gravitationally towards the inside, right? Just like a bottle of salad dressing, if you let it sit, the heavier particulates, right, the heavier particles will fall towards the bottom. And in this case, the bottom is near the central star. Okay? The lighter elements, like the oils in salad dressing, will rise to the top or the outer part. Okay? And that is analogous to the gas in this case. Okay? So, and that should be all the steps 1 through 7. Right? So here are the actual items listed in order. If you have any questions, please don't hesitate to message me. Otherwise, thanks for watching.